I will be somewhat brief. Thanks, Erica, for the introduction. Like Erica said, I'm from Nagase ChemteX. I've been with the company going on about 28 and a half years now. I'll be talking about our next generation conductive ink is stretchable conductive ink, as we feel like we've developed a new material that outperforms some of our previous materials. But we'll give a brief introduction on the company, talk about some of the goals we had during development, the challenges we faced in that time. We'll go through the data, the applications, and the key takeaways moving forward. So for those of you that don't know, Nagase ChemteX America, we started as Engineered Material Systems. EMS, an established innovator for primarily industrial adhesives, but it evolved into adhesives for electronics, solar, wind, print electronics applications, and was started in 1993. We began manufacturing in 95, and then it was in 2004 that we began manufacturing and developing conductive inks and dielectrics. EMS, we were acquired by Nagase in 2012, located in Delaware, Ohio. We've opened a new 64,000 square foot facility in 2015, which I guess isn't so new anymore. Quickly expanded to 109,000 square feet. And then we officially changed our name from Engineered Material Systems to Nagase ChemteX America in the middle of COVID in 2021. We've got ISO and IATF quality certifications. But enough about the company, and we can get into the project. So our goal in developing a new stretchable ink, durable ink, was primarily a silver ink. So, our commercial product had some challenges. While it gets good stretch performance, it did have some durability challenges. It would crack with snapping. Certain films with increased stretching, the stretchability would increase too exponentially. And then finally, the final project goal was to make sure we were highly conductive to present a good option to the wearable market. Some of the challenges we faced while developing the material. The biggest one is developing the silver to binder ratio, the filler level. It's not just as simple as adding more silver and becoming more conductive. And then along those lines, what happens as you add silver? What happens to stretch properties? What happens to crease properties? And if anybody's paid attention to the silver market recently, we are incredibly high. I think it was about $36.50 last I checked yesterday, which is challenging for many users. So we wanted to be mindful of that to optimize the level of filler, the silver that goes into the property. So what you're seeing here is a resistivity versus percent stretch plot. Okay, this are three different inks at different filler levels. A has the least amount of silver. C has the most amount of silver. And you can see that we made some significant improvements with B, and then we made some marginal improvements going to the C loading. So I'll get into it further but I guess my point is it's not, as I mentioned earlier, it's not just as easy as adding more silver, getting better resistivity or lower resistivity. But looking at the same data with the number of creases, what you see here is crease testing at three different line widths. There's a 0.38 millimeter, 0.5 millimeter, and a 1 millimeter line trace. And again, you can see A is higher than B, which is higher than C. So not much improvement going from B to C. So we have settled on level B for optimized performance and to optimize the cost of the system.